Hi, Derek. People are just working on the do now for now, just letting you know. And again, the second problem was misprinted, so ignore the second problem. Awesome. Thank you, Damani. Thanks, Damani, for submitting the do now.
We said the do now is the limit thingy.
Sorry, can you say that again, Daniel?
The do now is it the one that says limit drill?
Yes, yes, it is.
Oh, okay. God, I was kind of confused. Thank you.
Awesome. Thank you, Aaron. Thanks for showing all your work. Looks really good. Thank you, Mercy. Okay, I'm going to give one more minute and then I'm just going to go over the do now. And I would like everyone to have those 3 problems on the do now, except for number 2. The 3 other problems written down in their notebooks, just because it is good review, and that's kind of what we're doing today. Thank you, Zakaya. Awesome work.
Excuse me, are we supposed to turn that in? Like take a picture of it and turn it in?
Yeah, ideally. Again, I'm usually not grading the do now, so it's not the biggest deal. Like, what's more important to me is that you guys are working on it. So like, yeah, as long as you're like working on the problems, that's fine. If you can turn it in, then by all means, please do that, just so I can like see your work too and work off of that. But yeah. And Aaron, you said you love dinner because that is the biggest meal and that is when your dad cooks the most food. Gotcha. Awesome. That makes sense. I feel like it's got to be either, for me, it's either dinner or breakfast. But I definitely see dinner. Oh, Alexandra, you said you prefer dinner because you don't like breakfast. Gotcha. Yeah, I really like breakfast foods. generally. So I don't know. I do skip breakfast a lot though, but it's like when I can eat it, I enjoy it a lot. Okay, anyway, so now we're gonna move on to actually figuring out the do now. So I would say the first problem is definitely the hardest. Can I get Christian to start us off with, like, what did you do for this problem?
So for that problem, I substituted in the pi over 2 for x, and I realized that the denominator would be 0, so I just left it as undefined.
Gotcha. Yeah. So I think the first instinct when we look at any limit is usually just to substitute it in, right? So let's just try that. We do tangent of 2 times pi over 2 over pi over 2 minus pi over 2, right? And then if we evaluate this, you do realize that the denominator is 0. That's accurate, but most of the time when we're given limits, I think very, very rarely is the actual answer undefined. So I would try to solve the top two. So tangent of 2 times pi over 2 would just be tangent of pi, right? And what is tangent of pi? It is going to be 0, right? So that's just something you kind of have to memorize. If you visualize the unit circle, tangent of pi, like pi is at 180 degrees, right? So, and tangent is y over x, and at 180 degrees, y is 0. So the numerator is 0, so we know tangent of pi is 0. But anyway, so now we get 0 over 0. Zakaya, what does this like form? Like, what does that kind of tip you off to? Sorry, Zakaya, are you there right now?
Yes.
So I was just asking, so for this first problem, we plug everything in and we get 0 over 0.
Mm-hmm.
But is that the end of the problem?
No.
So what can you do to
You find
move
the
on?
derivative of tangent 2x, and I got 2 secant squared 2x, and then the derivative of x minus pi over 2 is 1.
Gotcha. Can you name the rule that we are using here then?
La Hospitalo, I believe.
Yeah, gotcha. Yeah, that's right. So it's L'Hopital's, right? So if you remember, whenever we do a limit and we get something like 0 over 0 or infinity over infinity, that definitely tips us off to, we might be able to use L'Hopital's here. So again, L'Hopital's is the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. So literally just finding the derivative of the top and the bottom. And yeah, so we're going to find the derivative of tangent 2x. Let's see. Zakaya, could you actually come off of mute again and kind of take us through what the derivative of tangent 2x is? I think this might be a bit challenging for some people, so.
I said the derivative was 2 secant squared, parentheses 2x.
Gotcha. So you had secant squared of 2x, because the derivative of tangent x is secant squared x, right? So we're going to have secant squared of 2x. And then why did you have a 2 in front here?
Because you have to bring it to the front, the 2 to the front. Mm-hmm.
Gotcha. Sorry, what do you mean by bringing it to the front?
Like, I don't, it's just like math, like you just bring it to the front. I don't know how to explain it. Like I know,
Okay,
like
can you name, would you be able to name the rule that you used when you?
Power rule.
Okay, So actually what we're doing here is a chain rule, right? So we're doing secant squared of 2x, and then you're finding the derivative of the inner function, which is 2x, right? So the derivative of 2x is 2.
Mm-hmm.
So multiply it by 2. So we're not actually doing power rule here, we're doing chain rule. And then we're finding the derivative of the bottom, which is x minus pi over 2, which is just 1.
And then I just substituted pi over 2.
Gotcha, yeah. Yeah, thank you for that. So we're gonna get 2 secant squared of 2 times pi over 2, which is equal to 2 secant squared of pi. And that is gonna be secant of pi is equal to -1. So it's gonna be equal to 2 times -1 squared, which is equal to 2. Okay, so for problems 3 and 4, we're going to employ like a common idea when we see that the limit is going to infinity, right? So when the limit is going to infinity, we're looking at n behavior limits. And hopefully you guys remember the concept of the hierarchy of dominance. This is from like our week 1 calc review or week 2 calc review maybe. And then something you guys should have learned in pre-calc too. But essentially we're going to isolate the dominant terms, right? There's only one term here in the numerator and denominator. So Renique, could I get you to come off of mute and tell us, like, between x to the 5th and e to the 5x, which term is more dominant?
E to the 5x.
Gotcha, yeah, exactly right. So since e to the 5x is more dominant, that means it's increasing a lot faster than x to the 5th, so it's going to be going to 0. So our answer here is just going to be 0. E to the 5x is more dominant than x to the 5th. Right, so what that means is we have basically x to the 5th, if you think about it, it's like really small. E to the 5x is comparatively much larger. So if you think about something that's really small divided by something that's really big, you're going to get something that's going to 0. And then along the same vein, Samantha, would you really come off of mute and tell us between natural log of x and x, which one is more dominant?
Natural log of x is more dominant.
Okay, so if you think about it, actually, it's actually x that's more dominant. So natural log of x, if you just draw it out, right, it kind of looks like this. I'm not sure if you guys have that visualized. But x is just going to be a straight line going up. Right, so yeah, this is kind of tricky because I think most people, when they think of like something that looks more complex, like natural log of x or log x, you're going to automatically think it's increasing faster than x, but it's actually not. So in this case, x is more dominant. So the limit as x approaches infinity of natural log of x over x is also equal to 0. Right, because x is larger than natural log of x. So it's the same idea, small over larger. And I don't have the exact like hierarchy of dominance written down or memorized right now, but generally, like we have terms like anything that's x to the x is more dominant than like e to the x. So e would be like any number, which is going to be larger than, let's say, x squared, which is larger than x. But x is larger than log of x or natural log of x or any of those. And actually, log of x, I believe, is larger than any radical, although I'm not 100% sure between these two because they both kind of look like this. So those might be switched. Might be useful to review that, but it's important to generally have this concept of the like more dominant and less dominant terms memorized.
So can you go up?
Yeah.
Thank you. Wait, can you go to the number 1 real quick, please?
Okay, hopefully everyone has notes copied down. I'm going to move on now to our second topic that we're reviewing today, which is optimization. So the question is, we are going to fence in a rectangular field that encloses 200 meters squared. If the cost of the materials for one pair of parallel sides is 3 feet and the cost of materials for the other pair of parallel sides is 8 feet, determine the dimensions of the field that will minimize the cost to build the fence around the field. Wait, can you guys hear me right now? Or I think my audio should be fine. Okay. All right, cool. So I'd like for everyone to take just 1 minute just to figure out what our constraint equation is in this case. So remember, the constraint equation is like the rule that we have to follow. It must be true. It's not the equation that we're trying to maximize or minimize. And I feel like for this one, it might be a little bit tricky to figure out what the constraint equation is. So I'll say, we have a rectangular field, right? Just to help with this visualization. And it encloses 200 meters squared. Let's say the sides are X and Y, just to help us with that. So what would the constraint equation be, given everything else in the problem? Mercy, great job. Thank you. Aaron, awesome. Thank you. Aaron, can I get you to come off mute, explain your answer, and then Mercy, can you follow up on that and just say if you agree or disagree?
So I think the constraint equation is xy equals 200 because
Awesome. And yeah, sorry, go ahead.
Yep.
Do you have like an explanation for that, or?
Because 200 is the area, and then they said that one pair of sides costs $3 per feet, so that would be the x, and then the cost of the other pair would be 8. So
Cool. And
that's how you can find the equation.
awesome. Mercy, could you come off of mute and just say whether you agree or disagree?
Yeah, I agree. It said xy equals 200 because the total area is 200. So like the two sides multiplied will give you the area.
Yeah, exactly right. So we can kind of tell this just from the first sentence alone. So we're going to fence in a rectangular field that encloses 200 meters. So let's say we have any rectangle, right, with sides x and y, and we're told that the area is 200. That means no matter what, x times y must equal 200, right? Like regardless of the other stuff that they tell us in the problem, we know that x times y must equal 200. So that's going to be our constraint equation. Now, I'd like for everyone to see if they can figure out the optimization equation, and this might be even more challenging. So just to help us out, I'm just going to kind of draw out a diagram. So the cost of material says that for one pair of parallel sides, right? So these would be parallel sides. So this and that, those are parallel sides. And then this side and that side would also be a pair of parallel sides. So it says one pair of parallel sides costs $3 per feet. So sorry, $3 per feet, right? And the other cost, let's say $8 per feet. All right, thank you, Aaron. Thanks for letting me know, Renique. So just to try to get a hint, right? We're trying to minimize the cost to build a fence around the field. So what does it mean when we're trying to figure out the cost of everything around a whole field, like around here? That means we're going to be looking for perimeter, right? Yeah, exactly. Thanks, Aaron. So we're going to be looking for perimeter. But we also want to incorporate these sides, the cost. So Renique, actually, can I get you to come off of mute and just talk about the first message you sent?
So basically, I remember like an example yesterday when we had to like minimize, we used like we use like everything had add up and we used that. So I was just like, they gave us, it's saying that we have to determine the dimensions that would minimize the cost of the fence
Mhm.
around the field. So I was just like, we have to do perimeter. So I had just known that perimeter was like all of the sides combined. So I just put P equals 2x plus 2y.
Okay, I think that's a good place to start. So we have P equals 2x plus 2y. So that's going to be our perimeter, right? Yeah, that's exactly right. But now we have to incorporate the cost, right? So, because we want to minimize the cost to build the entire fence around the field. And we know that every unit of X costs a certain amount, and then every unit of Y also costs a certain amount. Christian, would you want to come off of mute and kind of share what you put for your answer? Like, how would I adjust this equation to incorporate cost?
What I did was I put 2 and then I put 3x in parentheses plus 2 and then 8x in parentheses. And I guess like the 3 and the 8 will represent the price and the 2 is like each side.
Gotcha. Yep, that's exactly right. So basically, well, to explain the perimeter, right, we have two x's, right? We have two x sides, and then we add two y. So that's the perimeter. But we know that for each x, well, in this case, we can switch this around actually. So to reflect the drawing I did. But for each x, it costs $8 per square feet, right? So we're going to multiply the x by 8. And then for y, each unit, I guess, costs $3 per square feet. So we're going to multiply that by 3. So our whole perimeter cost is going to be 16x plus 6y. And Samantha, I saw that you got that as well. And Aaron, you got that too, so great job. So yeah, we are ultimately getting a perimeter of 16x plus 6y, and this is going to be our cost, right? So I guess I can write this as perimeter cost. So we'll say PC. Now, our next step is we want to minimize the perimeter cost, right? That's our ultimate goal, is we want to minimize perimeter cost. And currently I have an equation that's 16x plus 6y, and this is kind of hard to minimize, right? Because we have two variables. So Daniel, if we have two variables, could you come up with mute and kind of talk about how we would get rid of one of the variables?
How we get rid of one variable?
Yeah.
I'm thinking you should divide out. I don't know.
So
I'm not
try to
sure.
focus on the constraint equation here, right? Because we have x times y is equal to 200, right? And we have x and y here. So could we substitute in one of these?
So you're saying like, so we're gonna substitute like the 200 for like the y and the x?
Yeah, so that's basically the idea. So I can solve for, I can say x is equal to 200 over y, right?
Mm-hmm.
And then I can plug this in for x. So now x is going to be equal to, I'm just going to rewrite that down here. Thanks for sharing, Daniel. So x is equal to 200 over y. So now PC is equal to 16 times 200 over y, right? Instead of the x here, because x goes into there. So 200 over y plus 6y. So I'm going to simplify this out to PC is equal to 3200 over y plus y, and this is equal to 3200 y to the negative first power plus 6y. Awesome. So next, Aaron, would you be able to come off of mute and tell me if I want to find a maximum or a minimum for this? In this case, we want to find a minimum, right? We still want to minimize this equation. Like, how would I go about doing that?
You have to find the critical points.
Gotcha. So in order to do that, we're going to set this equal to 0. Oh, sorry. Not yet. We have to find the derivative and set that equal to 0. So PC prime is equal to, we're just going to do power rule. So -1 times 3200. I'm just showing all the steps for power rule here, right? Then we're adding 6 is equal to -3200 times y minus 2 plus 6. And we're going to set PC prime as, then PC is the perimeter cost, right? And that's what we're trying to minimize. We're going to set this equal to 0. And if I solve this out, personally, it makes it more easier for me if I put y squared down here. So I just moved y to the -2 again to the denominator because I feel like that's easier to deal with. And that is going to be equal to -6, right? I also moved the 6 to the other side of the equation. Now I multiplied both sides by y squared. So it's going to be -3200 equals -6y squared.
By negatives.
Yeah, awesome, thank you. So you divide by -6. So -3200 divided by -6 is equal to y squared. Just give a few seconds for everyone to copy this down. And then I'm going to do this math really quick. So this doesn't actually divide evenly, but it's going to be equal to 533 is equal to y squared. So y is equal to square root of 533.
Oh, yeah.
Now we want to check whether it's actually a minimum, right? So we're going to put a number line here. Square root of 533. And let's plug in a number to the left, right? So let's just plug in 1. So to find what the slope is at 1, but PC prime is equal to -3200 over y squared plus 6, right? And that's equal to -3200 over 1 plus 6. So that's obviously -3200 plus 6 is still going to be -3194, right? So it's going to be very negative. And which is good, right? Because if we want a minimum, we want to go from a negative slope to a positive slope. Now let's plug in something over here. So root 533, I'm not actually sure what number would be larger than that, but let's see. We can plug in, say, 30, because 30 squared is 900. So it's going to be larger than root 533. So let's say PC is equal to negative 3200 over 30 squared plus 6. That's going to be equal to negative 3200 over 900 plus 6. And that is equal to negative 3.5, repeating, negative 3200 over 900. I just did this on my calculator, is negative 3.5 plus 6 is going to be approximately like positive 2.5. So when we plug in this number, we get something positive. So that tells us that we indeed do have a minimum at root 533. So we can kind of just check this off. Nick, you said you have a question? Go ahead.
Yeah, so what happens if it's not a minimum? Like, let's say it's a maximum, or you get like 2 positives or 2 negatives.
Gotcha. Yeah. So basically, like the people who write the questions, they design it so that it's going to be a minimum. Also, I'm kind of taking like almost an extra step here, because theoretically, since we only have one critical point, right? We only got one critical point. We can be assured that it's the minimum. So because like there's no other critical point. So theoretically, like we don't have to absolutely do this. Like you can still get the right answer just by like assuming that it's a minimum. But I kind of just showed the number line just to prove that it is a minimum. Again, the problems you'll get, there's always going to be a minimum. It's not going to be a maximum just because of the way the question is written. So we have this step, right? We have y. We know that the cost will be at a minimum when y is equal to root 533. But now we also need to find x, right? Because it asks for the dimensions. And so we can kind of just look at our old equations. And I'll minimize this. Oh, it's very far up. So we have our constraint equation that x times y is equal to 200. So we can just plug in y there, right? Because remember, this is always going to be true. We have to follow this rule. So x, y is equal to 200. So that means x times root 533 is equal to 200. That means x is equal to 200 over root 533. So basically, these are our dimensions. And it's very unpleasant numbers, but these are our answers. Okay, so once you finish copying these notes, that's all I'm going to have for today. The exit ticket is going to be another related rates an optimization problem. I think in an easier related rates problem, basically, we finished up everything in Calc A. So starting very soon, we're just going to be jumping into Calc B material. So yeah, that will be coming up next. But that's all I have for class today. If you have any questions, you feel free to stay after class. But thank you everyone for coming, and I'll see you guys all tomorrow.
Can you go up to the do now? I forgot. I didn't write all the more.
Yeah. This part of the do now?
No, more down.
Okay.
Yeah.
And then Renique asked, when is the test? So I like talking with Ms. Sladek, like it doesn't seem like we have set out tasks for each unit now, just because stuff is going remote, and we just took a quiz. So I'm not sure if we're going to have a total test for this stuff. But if there is going to be one, I'll let you guys know.